When you catch a plane for a short or medium-range flight in Europe, it's highly likely that you'll be on an aircraft like an Airbus 320 or Boeing 737. These two aircraft families from Europe and America respectively are the backbone of most airlines around the world. Every day, more than 8,000 aircraft of these types take off somewhere. Their role in air transport is crucial, as is their impact on the environment. They've evolved a lot from a technological point of view since their introduction, but their manufacturers are already thinking about their successors. The new types will take wing near the end of the next decade, around 2020, and everyone's expecting a huge improvement in fuel consumption and environmental impact. A big role in this evolution is played by engines. This is the Snecma Aviation Engines factory near Paris, France. Here, highly skilled workers build one of the most popular engine families, the CFM56 that powers both Airbus and Boeing aircraft. Snecma is part of the French group Safran and works in a joint venture with US firm General Electric. There are more than 18,000 engines like these in service. Every 3 seconds, somewhere in the world, there's a takeoff with a CFM56 equipped aircraft. The engine entered service in 1982 and is offered in several variants with a thrust range from 8 to 15 tons. Engineers have worked hard on fuel efficiency and emissions. One variant, thanks to a new technology in the combustor, reduces nitrogen oxide emissions by as much as 45% compared to earlier versions.
Today, a modern plane equipped with modern motors has a fuel consumption that is expressed in a similar way to a motor car. That's to say, between 3 and 5 litres per 100 kilometres per passenger. An Airbus A380 consumes even less, around 3 litres per 100 kilometres per passenger. Between an original Boeing 707 and the new Airbus A380, there's been a more than 70% reduction in fuel consumption. We think a further gain of around 15% in the motors is possible.
Since the start of this century, the aviation community has set some environmental goals for 2020. Halve the perceived aircraft noise, reduce by 80% nitrogen oxide emissions, and reduce by 50% carbon dioxide emissions. CO2 reduction can be achieved mainly by aerodynamic and engine evolution, and also by more efficient and optimized flight operations, as we've seen in previous issues of Fly. To achieve these goals, the European Union's just launched the Clean Sky Research Programme, which is making a lot of resources from the European Commission and the industry available, and involves several universities and research centres from 16 countries. The Clean Sky Programme was officially launched at a recent aviation summit in Bordeaux, France. Euronews asked European Commission Vice President and Transport Commissioner Antonio Tajani, what's the strategy of the Commission in this field?
The European Commission is convinced that it is possible to marry the needs of aviation and environmental protection through several initiatives, beginning with the Single Sky 2 project, which I've proposed to the Parliament and to the Council. I hope that the project could be approved before the next European elections. The Single European Sky is a project aiming for a safer air transport system that will be less expensive, with more guarantees for citizens and also less polluting. It would be not only a system to reduce costs for airlines, and airlines are very happy with that, but it would also be a system to sharply reduce emissions of CO2 and other harmful gases.
But airlines are concerned about the European Commission decision to include aviation in the Emission Trading Scheme, or ETS, which means that airlines from 2013 will have to buy, like other industries, allowances for the emissions they release into the atmosphere.
We were extremely in favor of an ETS, at least at the inception, and that was valid for a cap-and-trade system. Now, what we have seen in the meantime is the developments of the concept from the original idea of having a pure cap-and-trade system to a concept that along the time mutated into something that resembles more a let's say, a tax system. So we're really extremely, let's say, worried and concerned that the system is unfortunately going nowhere, at the same time endangering the very notion of aviation in Europe.
I think that with the interpretation of the law, we have to get airlines to accept a project that moves towards environmental protection and that is concerned with climate change. At this time, the rules about air transport are already approved, so we have to try to reach an interpretation that won't penalize the competitiveness of European companies.
We return to the engine factory to see what technological research can bring us. What kind of engine will power the aircraft of the future? One solution is using contra-rotative fans.
Traditionally, motors use a giant fan at the front of the motor to push through a large quantity of air. We are testing a new type of fan, which instead of using a single set of blades at the front, uses two, which rotate slower and are more aerodynamically efficient. This provides more thrust for the same price, with the same consumption, and is quieter.
Another solution is the open rotor, an all-new engine architecture where the thrust comes from a big external fan.
The open rotor is one way of reducing consumption because it's the ultimate way of increasing air through flow, which creates the thrust. The problem with the open rotor is that in a classic engine design, these compressors are housed in a cowling, so the noise can be suppressed inside. The open rotor is exposed to the open air like on a helicopter, so the motor itself must be quieter, and there's no way of suppressing the noise after it's produced.
Another field of research is alternative fuels. Tests have already been done on biofuels, but to solve the carbon footprint problem, we must go further.
We need to talk about hydrogen, because in the end it's the only fuel that produces no greenhouse gases. It looks very seductive, and in terms of combustion in a turbo reactor, it presents no insurmountable problems. The difficulty with hydrogen is that it's very light. So you would have to imagine a plane of the future that looked more like a Zeppelin than a classic plane. That's certainly possible, but it would involve a complete rethink of air travel. So I think using hydrogen as an alternative fuel is not possible in the short or medium term, but could be imagined by, say, 2040 or 2050.
So it's possible to dream of an aviation system with zero emissions. But for the moment, we have to limit the emission footprint. Financial crisis or not, global air traffic is set to double by 2020. Only a serious research effort can help aviation to grow healthily.